Okay, very good morning, friends. It's 10 a.m., so we'll start with the session. Today we will see one of the important topic of data transaction, that is concurrency control mechanism, and in that we have to study protocols. There are various protocols, and today we have to study each protocol one by one. I am Mahesh Sanvi, working as Professor and Head, Department of Computer Engineering, SNJB's Letso KBGN College of Engineering, Chandwad. I hope you like this video and you will definitely subscribe my YouTube channel. So let's start with the today's agenda. Our today's agenda is we have to take care of what the revision session that we normally take every time. So review of last session. Then we'll see the concurrency control protocols. Then we'll see each and every protocol one by one. And finally, we'll end up with the summary of session. Let's start with the review session where we have seen the concurrency control mechanism. So concurrency control is the process or is the procedure in DBMS for managing simultaneous operations without conflicting with each other. So this concurrency itself is telling you that concurrency means one or more transactions will run concurrently or simultaneously. So when I'm talking about more than one transactions will run simultaneously, there will be problem of isolation and we have to take care of that. And that is the reason we need concurrency control mechanism. So what is the need of concurrency control mechanism? So you can see here, to resolve read and write conflict issues. So we have seen conflict operation, and that conflict operation is telling that at least one write operation must be there. So if such type of operations are there, we need to take care of such operations. We need to resolve such type of operations. Then the second point, to preserve database consistency through constantly preserving execution abstraction. So now this is again an important part, that database should remain always in consistent state, and that is possible if we take care of it. Third one, to apply isolation through mutual exclusion between conflicting transactions. So we need to take care that when we run two transactions parallelly, it should run in isolation. So that is the requirement given into the third need. The last one, that is concurrency control, helps to ensure serializability. So in my previous session, we have seen serializability, and we have even taken care that how serial schedule is useful, how non-serial schedule can be converted into serial schedule with the help of serializability with two types, conflict and view serializability. So we have seen this particular point. So let's focus on today's agenda, that is concurrency control, and we have various protocols with that. So there are basically four protocols that we have to study: log-based protocols, two-phase protocol, then timestamp based protocol, and finally validation based protocol. So we'll start with the log based protocols. So every protocol is important, and you can see that in examination, okay, in university examination, you can see the question is asked on each and every protocol. So all protocols are important and really easy to understand. Let's focus on the log-based protocol first. So log-based protocols, you need to focus here. There will be a lock. There will be a mechanism. We need to lock certain data items. So lock is a mechanism to control concurrent access to a data item. Concurrent access to data item means what? Suppose in transaction T1 and in transaction T2, there are certain operations like read and write, or any operations read or write. If they are accessing to same data item, let's say Q, in that case, we need to think about locking that data item to preserve its consistency. So here log-based protocol is telling you that the definition of log-based protocol is that the protocol that is based on this particular lock is mechanism to control concurrent access to data items. There are basically two lock modes. One is exclusive lock mode, where read and write operations are permissible, and it is denoted by lock X. It is denoted by lock X instruction. So the way we have seen the instructions like read and write, here there are two more instructions that we need to study today: lock X for exclusive lock mode and lock S for shared mode. Difference between exclusive lock mode and shared mode is that whenever you want to update any data item, update means what? You need to read as well as you need to write. Read the old value, update that value, and write that value again. Means write new value again. Means we need to open or we need to lock that data item using exclusive mode, that is using lock X mode, so that we can able to modify that. Suppose we only want to read the data, we don't want to update it, we don't want to modify it. Suppose we need to read the balance and we need to display that balance, we need to print that balance. In that case, only we need to open that lock, open that data for read access only. In that case, we can use shared mode lock, and this shared mode will help you to take care of the data item that can be opened using lock S mode, that is shared lock mode. So dear friends, there are only two types of locks. One is exclusive lock, another one is shared mode. Exclusive lock normally needs when we have read and write instructions. Shared mode will be useful when we have only read instruction but no write instruction. Now there is some rules based on it, because protocol itself is what? Collection of rules. So we need to understand what are the rules related to this. So lock request, suppose when we want any sort of data item, we need to give lock request. Once this lock request is given, then what will happen, this instruction will be, this command will be given to concurrency control manager. Now you can either use lockx command or lock S command. Lock X will be only when we need read and write. Lock S will be when we have to what? Access that particular data for read only mode. So here lock request will be given to concurrency control mechanism or concurrency control manager. And what concurrency manager will do, we can able to develop a program for managing this lock request. Okay, so programmer can able to give this kind of lock request. Once done, then transaction can proceed only after the request is granted. So unless concurrency control manager respond you or grant you permission for that lock, that particular transaction will be in waiting mode. So that transaction will be in what? Waiting mode. So that's the beauty of this. So you need to understand this mechanism. So let's look at on detailed part. Lock based protocols, there is basically lock compatibility mode. We have seen S is for shared lock and X is for exclusive lock. I have already told you that in shared mode, you can perform read operations only. In case of X lock, you can perform read and write operation. So any data item opened in what? S mode, then S mode for that is again permissible. Means what? Suppose there is data item, okay, there is data item which is actually, let's say we are writing certain instructions which will clear us an idea. Suppose T1 is there and T1 is saying that I have to read Q. Okay, there is T2. T2 is also saying that I have to read what? Q. So both are performing read operation. So when T1 is performing read operation and T2 is also performing read operation, so first we need to think about what? T1. When T1 is performing read operation and there is only read operation, naturally what will happen, lock S mode will be there. Okay, we will demand that we need to lock Q using S mode, that is shared mode, because there is only read operation. Once share mode is given, then again one more request, and here the request is granted. Just imagine that here the request is granted because there is no other transaction which is holding a lock on Q. So first time T1 is what? Holding lock on Q, and that is shared lock. Once shared lock is done, then T2 is also demanding for shared lock for the same data item, that is Q. In that case, this can also be granted. This can also be granted as S lock S. Lock S is permissible. How you will understand it is granted or not? So that is using that this particular compatibility lock mode. So you need to understand this compatibility lock mode, that is lock compatibility matrix, is telling you that when SS is there, it is true, means it is permissible. So you can open any data items, number of data items in shared mode is permissible. But once you lock it into what X mode, then you cannot even use shared mode for that. It means that again, if you focus here, suppose this is actually what performing transaction 1 is performing read and write operation both. Okay, in that case we need to lock this data item using exclusive mode. Okay, and as it is first time somebody is demanding for that, so naturally your concurrency control manager will what grant this permission. Once this permission is granted, then T2 just want to read the instruction. So what T2 will do, it will perform this instruction, that is lock SQ, and this will be not granted. This will be not granted. In that case, then T2 has to wait. Okay, T2 has to wait till this permission will be granted. And when this permission will be granted, then only then when T1 will release the lock. Unless T1 release the lock, T2 will not get the permission. So this you need to understand. This is the case of what exclusive mode lock. So once the data item is locked using exclusive mode, you cannot even lock it either by shared mode or exclusive mode, and that is cleared here with the help of this presentation. So SS, it is true. S with X, not allowed. X with X, not allowed. X with S, not allowed. So this matrix will tell you it is lock compatibility matrix. It is so simple, dear friends. You need to understand only shared is what allowed, but anything which is locked using X, it will not allow even for shared mode also. Now these are certain statements, 3 statements which is important. A transaction may be granted a lock on an item if the request lock is compatible with locks already held on the item by other transaction. In my previous example, I have already cleared you when we have locked the data item using S, and somebody is again, some other transaction is again demanding for the same data item by using lock S mode, then permission will be granted, and after permission only you can able to perform that transaction. Otherwise that transaction has to wait. Next instruction is important. Any number of transaction can hold shared locks on an data item. कितने भी shared mode के आप लॉक क्या कर सकते हैं, लगा सकते हैं, लेकिन एक बार exclusive mode का लॉक लगा दिया, उसके बाद कोई भी लॉकिंग नहीं चलेगा. So that is that particular thing you need to understand. So what will happen? Any write instruction comes means exclusive lock. Write instruction है यानी क्या आएगा? Exclusive lock. Okay, और सिर्फ read instruction रहेगा तो क्या आएगा? Shared. तो जब भी राइट इंस्ट्रक्शन आएगा, व्हाट विल हैपन माय डियर स्टूडेंट्स, इट विल नॉट अलो वंस इट इज लॉक्ड बाय सर्टेन ट्रांजैक्शन, अनदर ट्रांजैक्शन कैन नॉट एक्सेस. वो जब एक्सेस नहीं कर पाएगा, इसी को हम लोग क्या बोलते हैं, म्यूचुअल एक्सक्लूजन. यानी क्या, सम ट्रांजैक्शन इज परफॉर्मिंग ऑपरेशन ऑन इट, अदर ट्रांजैक्शन हैज टू वेट. अदर ट्रांजैक्शन हैज टू व्हाट, वेट. जब तक ये कंप्लीट नहीं कर देता इसका काम, तब तक ये नहीं होगा. तो ऑटोमेटिकली कंफ्लिक्ट ऑपरेशन जो है वो नहीं होगा, और कंफ्लिक्ट ऑपरेशन नहीं होगा तो हमारा जो प्रॉब्लम था कंफ्लिक्टिंग इंस्ट्रक्शन का, उसको हम लोग यहाँ पर क्या कर सकते हैं, सॉल्व कर सकते हैं बाय यूजिंग लॉक मोड. ओके, नाउ द थर्ड इंपॉर्टेंट स्टेटमेंट, इफ लॉक कैनॉट बी ग्रांटेड, द रिक्वेस्टिंग ट्रांजेक्शन इज made to wait till all incompatible locks held by other transactions have been released, and then only the lock is granted. यानी क्या, जब तक कोई डेटा आइटम को कोई ट्रांजैक्शन ने लॉक करके रखा है, जब तक वो रिलीज नहीं करेगा, दूसरा ट्रांजैक्शन हमेशा क्या रहेगा, वेटिंग में रहेगा. सो दैट्स द ब्यूटी, बट इट आल्सो हैज सम प्रॉब्लम्स. सो दैट आई विल टेल यू इनटू व्हाट सब्सिक्वेंट स्लाइड. Now take an example that I have already cleared you, but I'm again giving you this example. Transaction T2 is requesting for lock S, that is shared mode lock for data item A, because it has to only perform read operation. So it has performed that read operation, and unlock instruction is there. Okay, unlock instruction is there that will release the lock. Okay, lock S or lock X, both the instructions are there to acquire the lock. You can request the lock by using lock S for shared mode, lock X for exclusive mode, and unlock is enough to unlock instruction is enough to unlock exclusive as well as shared mode lock. Okay, so you can understand here both the instructions, both the data item A and data item B are only performing read operation because we need to display the addition of both the transactions, addition of both the data items. So what we are doing here, we are reading the value of A, so we locked in shared mode. We are reading the value of B, so again we locked into what? Shared mode. And finally we are unlocking both the data items. So that you need to understand, we are simply displaying the addition. So this is allowed. Now the next part, locking is not sufficient to guarantee serializability. Always remember, locking is not only sufficient to guarantee serializability. Serializability इसके बावजूद भी disturb हो सकता है. Okay, if A and B get updated in between, the read of A and B may display wrong sum. Means what? We are only talking about T2 here. If you focus here, what we are doing, we are only focusing on T2. There may be possibility that suppose we have one more transaction. Okay, we have one more transaction, and that transaction may be, let's say, T1. That can be your T1. If T1 is the transaction which is updating what? The value of A in between. क्योंकि ट्रांजेक्शन पैरेलली चल रहे हैं ना, कॉन्करेंट की बात हम लोग कर रहे हैं, तो क्या होगा? इन बिटवीन T1 ने क्या किया? A के वैल्यू को अपडेट किया, तब दोनों का समेशन क्या होगा? मैच नहीं होगा. दैट मींस दैट देयर विल बी प्रॉब्लम ऑफ कंसिस्टेंसी. सो दैट मे हैपन इन केस ऑफ व्हाट? लॉकिंग. सो लॉकिंग, okay, so you need to focus on this statement. The statement is telling you that locking is not sufficient to guarantee serializability. Locking is there, it will give you what? Some assurance, but it is not foolproof solution. That we have to understand. Okay, next part is a locking protocol is set of rules followed by all transactions while requesting and releasing locks. So what is locking protocol? It is set of rules. What kind of rules which will be there? So we have seen that compatibility matrix. What that compatibility matrix were telling us? Shared is allowed, but once it is locked using exclusive mode, then it is not allowed. In that case, some transaction may be always in waiting, and that may goes to what? Starvation issue. So I hope starvation issue should be known to you all. Otherwise, I'll definitely explain it into the next subsequent slides. लॉकिंग प्रोटोकॉल्स रेस्ट्रिक्ट द सेट ऑफ पॉसिबल शेड्यूल्स. बहुत सारे शेड्यूल्स जो भी है, पॉसिबल सीरियल शेड्यूल जो आप लोगों को इक्विवेलेंट सीरियल शेड्यूल जो बनाने हैं, ओके, लॉकिंग प्रोटोकॉल में रेस्ट्रिक्ट यू टू प्रिपेयर दैट. ओके, बिकॉज देयर विल बी अ एक्सक्लूसिव लॉक मोड, और till you what? Unlock that data item, another transaction will be always in waiting mode. So that you need to understand. Now the automatic acquisition of lock, how locks will be automatically acquired. You need to understand there is transactions Ti issues standard read or write instruction without explicit locking calls. Suppose there is transaction Ti which we want to execute, and we have what? Read and write operation there. It means that read and write means there will be updation on that particular data item. When data item will be updated, it is expected we need to lock it using exclusive lock mode. But here assumption is that we don't want to lock it. Okay, so once we have, suppose we have not locked, what will happen? The operations read D is processed as, okay, the operation read will be processed like that if Ti has a lock on D. If Ti has lock on D, यदि D को already Ti ने क्या करके रखा है? लॉक करके रखा है, then read D else begin. तब जाके D को आप लोग क्या करोगे? रीड को अलो करोगे. ओके, else begin if necessary wait until no other transaction has a lock X on D. Okay, then grant Ti a lock S on D. यानी क्या? अल्टीमेटली आपको इसमें से ये समझना है, ये पूरे इसमें से आपको सिंपल क्या समझना जरूरी है? When there is need of read, go for lock S. When there is need of read and write, go for what? Lock X. But you can even use lock X for read operation only. That depends on programmer. उसको यदि लगता है कि उसको lock X पे मोड ये करके रखना है, बाकी कोई उसको यूज नहीं कर पाएगा. So that will be the problem. So this is one of the issue. Okay, another part, the operation write D is processed as if Ti has a lock X. This was lock S. ये वाला इंस्ट्रक्शन जो भी ये क्या था? लॉक एस. मैं इसको एस कर देता हूं. डैश डैश लॉक एस। ये एक ये अपना हमारा जो भी इंस्ट्रक्शन था, दिस इज रिलेटेड टू व्हाट, शेयर्ड मोड। एंड नाउ वी आर फोकसिंग ऑन द नेक्स्ट इंस्ट्रक्शन, दैट इज लॉक एक्स। सपोज इफ टी आई हैज अ लॉक एक्स ऑन डी, यानी एक्सक्लूसिव मोड में डी को हम लोगों ने क्या करके रखा है, राइट कर, सॉरी लॉक करके रखा है। नेचुरली वी नीड टू परफॉर्म राइट ऑपरेशन। देन राइट ऑपरेशन Hello. Hello. I hope my voice is audible to you all again. Dear friends, am I audible? Can anyone will tell me? Yes. Okay. So again, I'm sharing my screen. Very sorry, due to issue of power supply, power failure. There was an issue. Anyways, I hope I'm audible to you all, and we can start with this. Okay. I'm simply Yeah, very sorry, friends. Hope I'm audible now. If I'm audible, can anyone please write down on chat window? Simply say yes if I'm audible so that I can start with this. Okay, thanks a lot, Mamta. So I'll start with this. So, yeah. So we were talking about this part. Okay, thank you all. Yeah, we were talking about this part, that is automatic acquisition of lock. Okay, suppose if we perform this lock X mode, we naturally know that only write operation is possible, and no other transaction can able to acquire any of the lock mode. But what if we have what lock X for this, and now we want to convert it into lock X? In that case, the same transaction can upgrade that lock on D to lock X. So upgrade is possible, and this can be granted because no other transaction is what accessing it. So it is possible. So all locks will be released at the end of commit or abort. So dear friends, from this you need to understand lock S is okay.
Friends, I'm so sorry that today there is some issue of internet also. Okay, uh, let me check whether this presentation is available with me on mobile. Give me 1 to 2 minutes only. Okay, friends, I was talking about this shared mode lock. Okay, sorry, two-phase locking protocol. What I will do, I'll share the whiteboard so that I can discuss with you on that particular point. Okay, so my point was, okay, I am sharing the whiteboard with you all. I hope I am audible to you all clearly. Okay. Okay. So talking about two-phase locking protocol. Okay. Two-phase. Okay. So two-phase locking protocol, there are basically two phases, first one and the second one. First one is saying that it is growing phase. Okay, it will be known as growing phase where all the lock request will be granted. Okay, there will be a growing phase where all the lock request will be granted. Okay, so those who will request for the locks, okay, and if it is possible, the request will be granted. So that's the beauty of what phase one, growing phase. Okay, so we have one more phase that is known as that particular phase is known as shrinking phase. Okay, it is known as shrinking phase. Kindly bear with my handwriting right now. Okay, so there will be two phases, growing phase and shrinking phase. In shrinking phase, all the locks will be what released, but no lock request will be granted. Understand this both so that the things will be quite clear to you. I'm talking about the first phase, that is growing phase. Growing phase is telling you that all lock requests will be granted, but no release request can be granted. In case of second phase, that is phase two, known as shrinking phase, where all the lock request for unlocking, means for releasing of lock, is granted, but it will not allow you to lock that particular data item. So it will not allow you to lock data item, and it will not allow you to unlock data item in growing phase. So growing phase में क्या होगा? You can able to lock the data item, but you cannot unlock. श्रिंकिंग फेज में क्या होगा? आप अनलॉक कर पाओगे लेकिन लॉक नहीं कर पाओगे. So this is the major difference between what two phase locking protocol. So first phase is telling you to acquire as many as lock that you want. For example, if we have, let's say we have an example where suppose we have lock modes. Okay, we have lock data item. We need what data item A as well as what data item B. And suppose there is transaction T1 and T2. Suppose T1 has acquired data item A and T2 has acquired data item B. Okay, there are transactions like T1 and transactions like T2 where data item A is acquired by T1 and data item B is acquired by T2. So once this is acquired, it indicates that this T1 is actually acquired A and waiting for B. T2 has acquired B but waiting for A. Means what? T1 is dependent on T2 for B. Okay, for B, and T2 is dependent on T1 for A. Okay, on T1 for A. Such a situation is known as deadlock. Okay, this situation is known as deadlock. You need to understand what I wanted to tell you. Suppose that I'm talking about what? There is transactions T1. Okay, transaction T2. T1 acquired lock on A and dependent on B, dependent on T2 for B. Okay, so it is acquired A and planning to acquire or waiting for B, which is already locked by transaction T2. B is locked by transaction T2. So what will happen? T1 is dependent on T2 for B, and T2 is dependent on what? T2 is dependent on T1 for A. Such a situation is known as deadlock. इसको हम लोग क्या बोलते हैं? डेडलॉक. ये क्या बात हो गई फ्रेंड्स? तो आपको ये समझना है. सपोज आपके पास एक ब्रिज है, एक सिंगल ब्रिज है, यहां से एक कार आ रहा है और यहां से भी एक कार आ रहा है, और एट ए टाइम एक ही कार इस ब्रिज के ऊपर से जा सकता है. ओके, एट ए टाइम एक ही कार इस ब्रिज के ऊपर से जा सकता है. अब क्या होगा? ये बंदा जो है ये पीछे नहीं हट रहा है. ये कौन है? T1. और ये बंदा जो भी ये कौन है? T2. ये भी पीछे नहीं हट रहा है. ये बोल रहा है तू पीछे ले, तू पीछे ले. तो यहाँ पे ये झगड़ा चल रहा है. ये जो भी झगड़ा चल रहा है, दिस सिचुएशन इज नोन एज व्हाट? डेडलॉक. ओके, दिस इज नोन एज डेडलॉक. सो हियर in this locking, two-phase locking protocol, there will be always a situation of deadlock. Now, how to handle deadlock? Suppose there is deadlock like T1 and T2. It is dependent on this. It is dependent on this. It means that there is cycle. जैसे ये साइकिल आएगा, यानी यहाँ पे हम लोग इसको क्या बोलेंगे? दिस इज नोन एज वेट फॉर ग्राफ. इसको क्या बोलेंगे? वेट फॉर ग्राफ. अब इसको वेट फॉर ग्राफ क्यों बोलते हैं वो समझिए फ्रेंड्स. T1 जो भी है इसने A को एक्वायर किया, ओके, और B के लिए डिपेंडेंट हो गया. B के लिए डिपेंडेंट हो गया T2 के ऊपर. T2 हैज एक्वायर्ड B एंड डिपेंडेंट ऑन T1 फॉर A. दोनों एक दूसरे के ऊपर डिपेंडेंट है. इन दोनों में से किसी एक को पीछे जाना होगा. यानी यदि आप लोगों को याद होगा कि मैं जो सिनारियो बता रहा था कि देयर इज ब्रिज वेयर वन कार इज हियर, अनदर कार इज हियर, एट ए टाइम एक ही कार इस ब्रिज के ऊपर से जा सकता है. तो आइदर इसको पीछे हटना होगा या फिर इसको पीछे हटना होगा. दोनों में से किसी एक को समझदारी लेनी होगी. पीछे हटना यानी क्या? रोल बैक. पीछे हटना यानी क्या? रोल बैक. यानी क्या? इन दोनों में से सपोज T1 इज देयर एंड T2 इज देयर, हो सकता है T1 को बैकआउट करना पड़ेगा, तब जाके क्या होगा? T2 विल बी पास्ड हियर और T1 क्या हो जाएगा? यहां पे आके वेटिंग में चला जाएगा. ओके, T1 इज ऑन वेटिंग. मैंने फिलहाल आप लोगों को डेडलॉक का प्रॉब्लम जो भी वो कैसे सॉल्व होगा, T1 को हम लोगों ने क्या कर दिया? रोल बैक किया. T1 बाहर आ गया पिक्चर से और T2 यहां से चला गया. जैसे ही T2 गया, T1 पिक्चर में आना चाह रहा था, लेकिन और एक ट्रांजेक्शन आया T3, वो भी यहां से चला गया. और एक ट्रांजेक्शन आया T4, वो भी यहां से चला गया. और एक ट्रांजेक्शन आया T5, वो भी यहां से चला गया. इस तरीके से सारा ट्रैफिक इधर से यहां से इधर जा रहा है. तब जाके T1 कंटिन्यूअसली वेटिंग मोड में है. कौन वेटिंग मोड में है? T1 इज इन वेटिंग मोड. ओके, ये जो वेटिंग मोड में वो होता है, इस प्रॉब्लम को हम लोग बोलते हैं स्टारवेशन. इसको हम लोग क्या बोलते हैं फ्रेंड्स? इसको हम लोग बोलते हैं स्टारवेशन. स्टारवेशन यानी क्या? ये ऐसा प्रॉब्लम है कि T1 यहाँ पे स्टाव हो चुका है, उसने समझदारी दिखाया, वो ब्रिज के साइड में आ गया, अब वो वेटिंग में है. T2 चला गया, T3 चला गया, T4 चला गया, T5 चला गया. ऐसे जितने भी गाड़ियां थी वो चली गई, और जो फर्स्ट गाड़ी थी दैट इज T1 इज इन वेटिंग. And due to this, there will be a biggest problem. So this is what the big issue, my dear friends. And to resolve this issue, we need to always focus on starvation as well as deadlock. तो deadlock का problem solve करने जाते हैं, starvation का problem आता है. Starvation का solve करने जाते हैं, तो प्रॉब्लम जो भी है वो किसका आएगा, डेडलॉक का आएगा. तो दोनों प्रॉब्लम्स जो भी है ये इंपॉर्टेंट है. एक तो मैंने बोला डेडलॉक का, और दूसरा मैंने आपको अभी अभी बताया जो कि है स्टारवेशन. ये दोनों प्रॉब्लम को हम लोगों को क्या करना पड़ेगा, सॉल्व करना पड़ेगा. सो विल सी व्हाट आर द स्कीम्स व्हिच आर अवेलेबल टू सॉल्व बोथ दिस प्रॉब्लम्स. ओके, सो यहां तक आज के लेक्चर में इतना ही मुझे आप लोगों को देना था. मैं आप सभी लोगों को अटेंडेंस जो है वो शेयर करने की कोशिश कर रहा हूं. जस्ट वेट फॉर अ मिनट. ओके, जस्ट वेट फॉर अ मिनट so that I'll share with you. I'm copying the link of attendance. चैट विंडो में मैं अटेंडेंस का लिंक जो भी वो भेज चुका हूं दोस्तों. ओके, चैट विंडो ऑफ Zoom, I have shared the attendance. Okay, and now I'm sharing the attendance on YouTube also. Okay, I'm sharing the attendance on YouTube also. So I've shared the attendance on both. Please mark your attendance. I'm so sorry for the inconvenience today. Okay, this is normally happens due to some technical issue. I'm very sorry. Okay, and I'll definitely take care from the next time. Okay, dear friends, now you can mark your attendance and you can leave the meeting for the next lecture. Thank you all. If you have doubt, you can please ask. I'm not sure that whether you have understood this or not, but definitely I'll take revision, and in revision I'll cover this two-phase lock protocol again. Okay, thank you all. I'm